Okay, what about our example now? There is a building everywhere. Okay. The height of this building is 60 meters. I am supposing that when we talk about the example, we are understanding what is the example. And we have many heights. 1, 2, 3, 4. Yes. 1, 2, 3, 4. 1, 2, 3, 4 points. At each point, 20 meters. So this is 20 meters. This is 40. This is 60. This is simple. And this is 0. What else? What is the mass? We have an object with mass equal to 5 kilograms. طيب. Start from y1. That's y1. Okay. y1 is here. 2, y3, y4. With velocity v, v1 is equal to 0. Free fall. طيب. Compute the potential energy, the kinetic energy, the mechanical energy at each point. Yes, right. We need to find everything everywhere. And we don't have any frictional force. Any question how? What does the question mean? Huh? Let us start with point number 1. The main relation now, we need to write it always. The mechanical energy is equal to kinetic energy plus potential energy. Our potential energy is just a gravitational potential energy. If we have another potential energy, for example, elastic potential energy, we need to put it. Because this potential energy is 2 parts. But we have just the gravitational potential energy. Okay. At point number 1, the mechanical energy at point number 1 is equal to the kinetic energy and the potential energy at point number 1. Okay. If you like to compute everything alone, every term alone, separately, you can do that. If you like to do them all together, you are free to do that. So the mechanical energy at the first point, the kinetic energy, 1/2 mv1 squared plus mg y1. It's very, very simple. The kinetic energy is given. The potential energy is given. I need to use them at the first point. Okay, this is equal to the half. It's just the half. The mass is 5. The velocity at the first point is 0 squared plus the mass is 5. G is 9.8. I like to use 10, but I have to teach you the right magnitude, which is y1 is 60, right? This will give us 0 plus this thing. It will be the mechanical energy will be equal to 2,940 joules. The kinetic energy is equal to 0. The kinetic energy is 0. The potential energy is equal to 2,940. All of the energy is a potential energy. Now at point 2, the mechanical energy at point number 2 should be equal to the mechanical energy at point number 1, which is equal to 2,940 joules. should be equal to the kinetic energy 1 over 2, 5 multiplied by V2 squared. I don't know how much V2. Plus the potential energy at that point. I can use all of this term as kinetic energy too. It's okay. I'll use it like this. Plus M, the potential energy at point number 2. It is 5 multiplied by the altitude, which is 40, by G also, 9.8. So 2,940 is equal to the kinetic energy at point number 2 plus that number, which is at point number 2, the potential energy is 1,960 joules. What is the kinetic energy in this case? It is this minus that. So the kinetic energy is equal to 2,940 minus 1,960. It will be equal to 980 joules. This is the kinetic energy. I will talk about them. Now, what about the third point? I'll remove this because we already know everything about them. The third point, the mechanical energy is always the same. We don't need to name the mechanical energy by 1, 2, 3, and so on, because it is the same. The mechanical energy is always 2,940 joules. It is equal to the kinetic energy at point number 3 plus the potential energy at point number 3 now, which is M or 5 kilograms, 9.8, which is G, and the altitude at the third point, which is 20 meters. From that, kinetic energy is equal to 2,940 minus the potential energy at the third point, which is 980 joules, which is equal to, just replace this, the 1960 joules. This is the kinetic energy at point number 3. The point number 4, it is not total trivia. We have at point number 4, the mechanical energy is equal to the same thing, 940 40 with 2,000 joules. This is equal to the kinetic energy at point number 4 plus the potential energy at point number 4. The potential energy, it is mgy. How much y at point number 4? How much y, the altitude? It was 60, 40, 20, then 0. So the potential energy at the fourth point is equal to 0. The mechanical energy, all of it, is equal to the kinetic energy. Look, we have a mechanical energy, 2,940. It was totally potential energy. Then, by starting moving, because we don't have velocity, we don't have kinetic energy. Because the object starts accelerated, the velocity starts increasing. The velocity starts increasing, the kinetic energy starts increasing until the kinetic energy consume or will be all the mechanical energy at y equals 0. Okay? We can draw a graph, talk about this thing. And I suppose the graphs should be understood to you by dealing with the graphs in your life and in the lab. This is the building, and this is our graph. This is the mechanical energy, or the kinetic energy, and not or, and the potential energy. Our total mechanical energy is, this is the total mechanical energy. It is equal to 2,940 joules. Here, we can put Y, which is the position. We have 4 positions, 4 situations, at 0, at 60, this is 20, and this is 40. We have 4 points. We have a mechanical energy, we have a kinetic energy, we have a potential energy. At the beginning, now I need to draw the potential energy, and I draw it as point, as square point. The potential energy, initially, how much it was? Here, it was the maximum value of the energy, which is here, 2,940. And we have the values, 1960. And we have 980, right? And we have the 0. At y equal to 0, the potential energy is 0. The potential energy is a circle. The potential energy is a circle. At y equals 0, the potential energy is 0. At y equals 60, the potential energy is the maximum value. At y equal 40, the potential energy is equal to 1,960 at this point. At point 20 meters, potential energy is equal to 980. What about the kinetic energy? The kinetic energy will be a square. At 60 meters at the top of the building, the kinetic energy is 0. Then the kinetic energy starts increasing at 40 meters. Then it continues increasing. Then the maximum value of the kinetic energy at x equal to 0. At each point, if you add the square to the circle, it will give us 2,940. The square at 0, this is at the top. If you add this to this, it will give you all of this. Move this to here, it will give you the total energy. Because of that, our mechanical energy is conserved. It is conserved and the constant. The slope of this line is 0. There's no change in it. And the kinetic and the potential energy are changing. Are changing because what? Because the position is changing and the velocity is changing. Any question about this? Previously, I asked you to find the velocity. V final, V2 is equal to V1 plus 18. You need to use these equations. But in when we use the energy technique, we can use the velocity anywhere. For example, at point number 1, we have the kinetic energy equal to 0, which is equal to 1 over 2. M is equal to 5. V1 squared equal to 0. That means V1 is equal to the square root of the 0, which is 0. What about point 2? Kinetic energy is equal to 980, and it is equal to 1/2 multiplied by 5. V this is at point 1, this is at point 2. This is V2 squared. So V2 will be equal to the square root of 2 over 5 multiplied by 980. You can't find it. You will find two values, plus and minus. Which one we need to use? Is it the positive or the negative one? Our direction downward. The positive direction is upward. In this case, we need to use the negative sign because the direction is downward. What about V3? Kinetic energy at point number 3 is equal to 1960. This will be equal to 1/2. The mass is 5. V3 squared. Okay, V3 is equal to the negative root of 2 over 5, 1960 meters per second. The negative side because we are going downward. And the same for the fourth velocity. As you see, we are not using this equation, for example. V2 is equal to V1 plus AT. Or V2 squared is equal to V1 squared plus 2AY or AX. Or X equal to something. We don't use these equations. And in this case also, we don't care about the acceleration. If the acceleration is not constant, here in these equations, we need the acceleration to be constant. But here, if the acceleration is not constant, we don't care about it.